Okay, so now we're going to talk about confidence intervals. We're going to apply our theory of the sampling distribution to do some inference. We're going to use confidence intervals, or confidence intervals are used to estimate one population proportion and also the difference in two population proportions. So let's look at this research question. What proportion of Madison homes have 3 bedrooms? Now, we can imagine the realtor wants to know the answer to this, or someone studying demography, or whatever. But that's our question. Of all Madison homes, what proportion, what fraction, what percentage have 3 bedrooms? So when we use our Dane County home data, we find that 664 of the 1,128 houses had 3 bedrooms. And it's a proportion that's 0.59 or 59%. Now that was just 1,128 homes out of all the houses in Madison. Does that mean for the whole city the proportion is 0.59? Well, no, of course not. It's just one random sample. Our sample proportion is 0.59, and we're trying to estimate the population proportion, P. So we had a sample of P hat, the hat means that's the sample, of 0.59, and we're trying to use that to estimate the whole population proportion, P. Different samples would have different proportions. So a different sample might give us 0.60 or 0.58 or 0.56. There's variation, but how much? Well, we saw when we talked about the sampling distribution that the standard deviation of the sample proportions is square root of p1 minus p over n. So we always expect some variation when we take samples, and a theory from the last time told us how much that variation is, told us what the variation looks like. Variation, the standard deviation is given by our formula. So we don't know what p is, and we're trying to estimate. That's exactly the thing we're trying to estimate, but we can estimate the standard deviation just using our p hat. So we can use this and this to estimate our actual standard deviation. So notice here we're using p hat in place of p, but that gives us a pretty good estimate for the amount of variation there'll be in the sample proportions. And that gives us 0.015. So sure, different samples will give us different proportions. But on average, the sample proportions are only going to vary by about 0.015. Now whatever p is, 95% of the sample proportions are going to be within 2 standard deviations of that. So whatever p is, we don't know it, but whatever it is, 95% of the time our sample proportion will be within 2 standard deviation, 2 times 0.013, or about 0.013 of whatever the p is. So remember, p is some unknown number that we're trying to estimate. 95% of the sample proportions, though, because it's a normal distribution, 95% of the sample proportions are within 2 standard deviations of that. Well, our sample proportion was 0.59, so it's probably no more than 0.03 away from the p we found. So this tells us we can be 95% confident that p is in the range 0.59 minus 0.03 to 0.59 plus 0.03. The only way this could be true is if p was in this range. Okay, so our sample proportion, our 0.59, is probably close to p, so p is probably close to our sample proportion. That's what it comes down to. So based on our sample, we are 95% confident that the proportion of all Madison homes with 3 bedrooms is between 0.56 and 0.62. And this is called a 95% confidence interval. Now, there's a lot going on there, and a lot of yucky details, but it's not that hard. In our sample, 59% of the homes had 3 bedrooms. So the proportion for the whole city is probably close to 59%. How close? 2 standard deviations, and we use our formula to estimate how much that is. And how probably? 95%, because in the normal distribution, 2 standard deviations on either side of the mean represents 95% of all possibilities. Now we've got an Excel template that I created that'll do all the number crunching for us. So all the sort of calculational details where we can screw up with our calculator and norm dist, we've eliminated that for better or worse with this Excel template. So we enter the stuff that's in yellow here when we open the procedure template from our data section of our website. The sample size n, we just enter that. Our sample proportion 0.59, and then here we enter how confident we want to be. So usually we talk about 95% confidence intervals, but we could also talk about 98% confidence intervals and 99% confidence intervals. The most common ones are 95%. And then Excel does the rest. It tells us that, oh, you want to be 95% confident, then you have to go plus or minus, well, I was saying 2 standard deviations, but if you get technical, it's 1.96 standard deviations from the mean. And then how much do the proportions vary? How much do the sample proportions vary? Well, that standard deviation is approximately 0.015. It's called the standard error of the proportion. It's an estimate for the standard deviation. And then here's what we really need. The confidence interval is from 0.56 to 0.617 or 0.62. And another way of thinking of it is that it's 0.59, the number sample proportion, plus or minus this margin of error of 0.029. So Excel will take all the headaches away from us, and we can focus on interpreting and understanding what it's telling us. And a very similar theory will estimate the difference between two population proportions. So for example, what is the difference between the proportion of Madison homes that have 3 bedrooms and the proportion of Maple Bluff homes that have 3 bedrooms? So when we filter our data in Excel, we get that 664 out of 1,128 Madison homes had 3 bedrooms. We already saw that. And 9 out of the 30 Maple Bluff homes that were for sale had 3 bedrooms. And the proportions are quite different, 0.59 to 0.3. The theory is very similar to what we just talked about. And again, Excel will do the hard work for us. We enter the data up here in the yellow sections. And then down here, it tells us what the confidence interval is, from 0.124 to 0.456. So this tells us we can be 95% confident that the difference between Madison homes with 3 bedrooms, the proportion of Madison homes with 3 bedrooms, and the proportion of Maple Bluff homes with 3 bedrooms is between about 12.5% and almost 46%. So Madison, the larger proportion of Madison homes have 3 bedrooms, and it might be as little as 12.5 percentage points different from Maple Bluff to as much as 46 percentage points. So the proportion might differ that much. And in summary, the big idea is when we want to estimate one population proportion or the difference in 2 population proportions, we find out what it is for a sample, and then we use our normal distribution theory, our sampling distribution theory, to estimate how far away we could be from the population parameter, the thing we really want to know. So now it's just a question of getting some practice.